Hi guys, and welcome to this video where we're going to go over the Unit 1 Independent Task 2, okay? So again, like usual, here are our 5 topics. So we've got polynomials, we've got inequalities, which you would have noticed include some graph sketching, an actual graph sketching question, sine and cosine rule, and trigonometric identities, okay? So you should have already had a go at these 5 questions, and then you should have got to a certain level of support. So remember, make a note of where you got, of what level you used. Remember, if you just did it completely fine, then you didn't even need a level of support. So that's excellent, okay? So we're going to go through each question now. So the first one was polynomials, okay? So I want to factorize completely this cubic by here. So I've got 2x cubed plus 3x squared minus 18x plus 8. And I want to factorize this. Now, the first thing that we need to do is use a bit of factor theorem, okay, and try and find a factor that goes into this, okay? So to do that, what I need to do first is I need to let f of x equal my function. So that's the 2x cubed plus 3x squared minus 18x plus 8. Okay, that's what I'm going to do first. Now, all I'm going to do is I'm going to just sub in some numbers. So the first one I'm going to try is I'm going to try 1. Okay, so I'm going to substitute 1 into the equations. If I do that, I go 2 times 1 cubed plus 3 times 1 squared minus 18 and then times 1 and then plus 8. Now, if I type that in my calculator, okay, I get -5. Which means it's not a factor. What I'm trying to get here is I'm trying to get this to equal 0. If it equals 0, it means I found a factor, okay? So what I'm going to do now is I'm going to flip that, and I'm going to do f of -1, okay? Now, we could write it out again with -1s in it, but I'm going to speed up the process here. If I change all these for -1s now, everything in a bracket, I end up with 27, okay? So it's still not a factor. So next thing I'm going to do is I'm going to try 2. Okay, now when we do 2, we do get it equal to 0, which is what we want it to be. So I'm going to put therefore, now this is important now, whatever's inside this bracket, we flip the sign. Okay, so I've got x minus 2 is a factor. Okay, now let's say that didn't work. I would then go to -2, then I'd try 3 and -3 and so on. Okay, so keep working like that. Don't forget about your negatives. This is a really, really common one that people forget. Okay. So now you've got a couple of different scenarios you can go from here. Okay, you can either use algebraic division, okay, or you can use comparing coefficients. I prefer comparing coefficients. That's what I'm going to use. So if I've got and I write down my equation, my original one, I've got 2x cubed plus 3x squared minus 18x plus 8. That's just my function from the question. Should equal. Now I know one of my brackets is x minus 2. That's what I've just found. Okay, and my other bracket should be some sort of quadratic in a normal format like this. Okay, now what comparing coefficients is going to allow me to do, okay, is if I think about how I would expand this right-hand side, what terms would it end up with on this left-hand side? So if I look at the coefficients, for example, of x cubed, okay, on this left-hand side, the coefficient is 2. Okay, that's this number here. Okay, if I look at it on this right-hand side, the only way of making x cubed is by doing x times x squared over here. Okay, and if I times those two, I would end up with ax cubed like so. Okay, which means my coefficient would just be a. Okay, so my coefficient is a there. Okay, so that's what I'm going to start with. The next one I'm going to look at, I'm not going to look at the x squareds of the x. I'm going to go straight to the constants. Okay. I'm going to compare the constants. Okay, and I'm doing this for a reason, because if I compare the coefficients of x squared, of x cubed, it's always going to be to do with my a. And if I look at the constants, the only way of keeping it constant is the last two. Okay, so on this left-hand side, I've got 8. On this right-hand side, it would be -2 times c. That's the only way I can keep it a constant and not have any letters involved. Okay, and straight away I can solve that again, and I get -4. Okay. Now, the final one I need to find is b. So I found a and I found b. I need to find b now. The only two options I have is either looking at the x squareds or looking at the x. Now, it doesn't matter which one you look at, but what I tend to say is try and stick with the same one every time. So I always look at the x squared. So I'm going to look at the coefficients of x squared. Okay, so on this left-hand side, I've got 3. On this right-hand side, this is the harder bit now, okay? To get the x squared, I could do x times x, so this middle term. Now that would give me bx squared, so that's one coefficient. So I've got b. Another way of keeping an x squared is doing minus 2 times this first term, which would give me, in this case, minus 2ax squared. That's another term that I could have, so that's a minus 2a. Okay, now I can solve this because I know what a is. A is 2, okay? So that means b must be 7 in this case, because minus 2a would be minus 4, and I'd add it to the other side, gives me 7. Okay, now I'm running out of space here, so I'm going to go over to the side. Okay, obviously we'd normally keep going down the page. Now what I can say, okay, is that my starting cubic, so 2x cubed plus 3x squared minus 18x plus 8. Okay, now equals x minus 2, and now I've got a quadratic by here, 2x squared, because a was 2, plus 7x, because b was 7, minus 4. Okay, and I need to factorize that second quadratic into a double bracket. Okay, now you can either do it bit by doing splitting the middle term. Some of you just do by a bit of trial and improvement, which also works. But what you should have at the end is 2x minus 1 as one bracket and x plus 4 as the other. Okay, so there's my final answer. There's it all factorized out, okay, or factorized up. So what we can do is we can use our calculator to check. Okay, now obviously our calculator does do solving for us. Okay, so we can use that to our advantage. Remember, if you are using that, you will not get all the 6 marks if you use it and just give an answer. Okay, you have to follow all these steps. Okay, as I said, for this bit in the bottom left by here, okay, we could have done algebraic division, long division, and got it the same way. Okay, but the whole thing is what I'm trying to do is I'm trying to find this extra quadratic here in the brackets. Okay, so question 2. Okay, we've got some inequalities. Now I've got a little set of axes here. Realistically, we're looking at sketches. However, we do need to, for 5 marks, we're not just drawing a really quick sketch. We need to make sure we're like labeling some key points on my graph and thinking about how these look. Okay, so I've got some 2 inequalities here. Now again, I'm going to ignore the inequality sign for now. I'm going to look at just plotting let me get rid of that, sorry. I'm going to look at just plotting the quadratics that I've got there, or the curves that I've got there. Okay, so the first one is y equals x squared plus 4x minus 12. Now straight away, I know that this is going to have that kind of U-shaped curve. Okay, so what I'm going to try and find now is I'm trying to find wedge across the y-axis, okay, maybe wedge across the x-axis as well, and then also think about where's this minimum at, okay, because we can use some different things for that, okay? So the first thing I'm going to do is okay, when y is 0, okay, so this is going to be on the x-axis. I've got 0 is x, here in our brackets, is x squared plus 4x minus 12. And what I'm going to do is I'm basically going to factorize that. I'm going to solve it. Okay, so if I factorize it really quickly, I get x plus 6, x minus 2, so x must be minus 6, and x must be minus 2. Oh, sorry, but positive 2. Okay, so it's going to cross 2 and at minus 6. Okay, so that's the first thing I can see here. Okay, now the next thing I'm going to do is I'm going to do, okay, what happens when x is 0? So what happens on the y-axis? Okay, if I sub in x is 0, I get y is minus 12. So it's going to cross the y-axis all the way down here. Okay, now what's important is that because of symmetry, we should have our minimum down here, this bit down the bottom of my curve, halfway between where it crosses my x-axis. So it should have a minimum of minus 2. Now we can find the minimum by doing completing the square. Okay, so if I do completing the square, I get x plus 2 all squared, and I'm going to take away the square of 2, which is 4, and take away another 12, that's still there. Gives me... Okay, now what that allows me to do is basically the minimum, this bottom of my curve, is going to be, I'm going to flip the sign inside the bracket, and I'm going to keep the sign outside. Okay, so that's where my minimum is going to be. So it's going to be, that's off my graph, which is a little bit annoying, but it should be roughly around here. Okay, so those are the key points. Okay, so what I now need to do, which I'm going to struggle with on my trackpad, okay, but I'm going to kind of draw as best as I can a nice curve through these points, okay? So if I go, I'm going to start from the bottom. I'm going to work my way up this side first. So I'm going to go up through 12. I need to make it a bit steeper, a bit steeper, a bit steeper. Okay, and it's a really, really roach curve. I'm really annoyed by that. I'm going to do it again. Okay, you can see what we're trying to get at here. Let's go down this time. Okay, and then I need to go back up the other side. I want to go down instead, I think. I've come off the page a little bit there. There we go. Okay, now obviously you should have one smooth curve. Okay, mine's not a fantastic drawing. As I said, trackpads are really, really difficult to use on this. Okay, there's my first curve. That's that curve there. Okay, the next one I'm going to look at is a little bit easier. Okay, I'm going to look at y equals 4 minus x squared. Now you notice it's a minus x squared, so it should now be an N shape. Okay, so again, if I do y equals 0, okay, and I solve it, I'm going to get 0 equals 4 minus x squared. So x squared must be 4. So x must be plus or minus 2. So it's going to cross at plus and minus 2. Okay, then I'm also going to do when x is 0. If I do that, y is equal to 4. So it's going to cross at 4 at the top. So that's going to be my peak. Okay, because that is halfway between. Now, if I just draw my curve here, it should be a little bit easier. Okay, so here we go. Okay, and there's my two curves. Now, it did ask me to shade a region now. So once I've got my curves drawn, what I'm going to look at is I'm going to look at the regions. If I look at the blue one, I want it greater than this curve, which means I want it above, so in the inside of the U, in other words. Okay. The next one, for the red one, I want it less than it. So I want it underneath this curve. Okay, so I want it above the blue one, but under the red one. Happens to be this lovely middle region by here. Okay, now don't always assume it's going to be the middle region. More often than not, it is. Okay, but it's not always that middle region. Okay, so you need to make sure you are labeling these key points, especially for 5 marks. Okay, if it's just worth like 2 or 3, then it's expecting a lot less information. We could draw a much quicker sketch. Okay, because with 5, I've gone that extra mile and I've found out all those key points. Okay, so question 3, sorry. We got some actual graph sketching here. Okay, quite difficult one here. So I've got the curve C1 has the equation of this. I'm going to write it over to the side. I've got y equals minus a over x squared. Okay, so we'll separate them out. And then I've got curve 2, which has an equation of y equals x squared and then 3x plus b. Okay, now, again, A is a positive constant, that's really important, and B is a positive constant, okay? So A and B are both positives. Now, if I want to sketch C1 and C2 on the same axes, okay, showing clearly the coordinates of any points where the curves touch or cross the axes, okay? So it's told me what kind of key points I need, okay? So first I'm going to look at is I'm going to look at this minus A over x squared, okay? Now, as a little bit of rough working and understanding, we should know what y of a over x squared looks like in general. Okay, now this looks like a little bit like this. Okay. Okay, so if it's a negative, that is going to flip along the x-axis. Okay, so let me get my axes drawn for myself here. Which way is this open if I do it? I want to go the other way, don't I? Okay, get rid of that. In fact, I can't do that, can I? So let me start again. Let's draw some axes on, shall we? I want to go, because I want some negative points as well, don't I? So here we go, that's the x-axis, and here's the y-axis. Okay, so as I said, this blue one here, this first one, it's going to be the negative version of this. So it's going to flip along the x-axis. So it's not going to actually cross anything, but it is going to kind of go up like this, and then get ever closer to the x-axis but never touch it. Okay, so remember it's got some asymptotes. And this one's kind of going to do the opposite, like so. It's rubbish. Let me go back again. Okay, that is my y equals minus a over x squared. Okay, it's got asymptotes, but it hasn't asked me about them. It's just asked when it cross. It doesn't actually cross at any point. Okay, the next one I'm going to look at is I'm going to look at my y equals x squared and then 3x plus b. Now, this is a cubic. Okay, if I expanded that bracket, I would end up with 3x cubed plus b x squared. That's a cubic, which means, and it's a positive cubic, which means I should have something that has a shape like this. Okay, so if I solve this, so I think about, okay, when y is 0, it's already factorized for me. So I've got 0 is x squared and then brackets 3x plus b. So that means either the first thing 0, so x is 0, or it means this bracket is 0. And if I solve that, I get minus b over 3. Okay, so it's going to cross it only at 2 points. Now, if we look at this, we'd expect to cross at 3, wouldn't we? But that means that this, where's x equals 0, must be this minimum down here. So if I draw a line across there, and that was my axis, okay, it's going to cross over here, which is minus b over 3, and it's going to cross at 0, 0, so by here. Okay, so it's going to go something like this. Okay, it's going to come up past b. I'm going to do my top bit. It's going to come down. It's going to hit this, and then it's going to shoot back up again, and then it's going to come down here. Now, let me label. This is minus b over 3. This bit is 0. Okay, and it's also crossing the x-axis, at the y-axis of that as well. Okay, so that's my graph done. Okay, which means if you look, this is where it crosses. Now, it hasn't asked me necessarily for that point, okay, but they cross at that 1 point by there. Okay, and that's what I'm looking for part A. Okay, part B, let me draw a line down here and we'll get part B done. Part B, using your sketch, state, given reasons, the number of solutions for the equation of this. Now, you'll notice these kind of have the same aspects as before, and we'll look at the algebra now. But if we look at the two curves, they only cross at 1 point, don't they? Okay, so because they only cross at 1 point, this must only have one solution. Okay, so I'm going to write that, okay? The two curves only cross, sorry, already intersect, is a better word, intersect at 1 point. Okay, so I'm going to look at the two equations now. I'm going to try and get to this bit by here. Okay, so I'm going to say they're equal to each other. That's how we solve two curves if they're going to intersect. We look at when they're equal to each other. So I've got minus a over x squared is equal to x squared then 3x plus b. Okay, and I'm going to slowly make it look like the equation. So I'm going to firstly times by x squared. Okay, that's going to get rid of the denominator over here. So I got minus a is x to the power of 4 and then 3x plus b. And I'm going to add on my a. So I've got 0 is x to the 4 and then 3x plus b. Okay, so that's when they're going to be equal to each other, plus a. Okay, so I'm going to say, therefore, this has only one real solution. Has only one real solution. Okay, but the key kind of aspect is that I'm looking at my graph and I'm going, yeah, it only crosses at 1 point, so it has to only have one solution. Okay, so we've got 2 more questions to go. Okay, for question 4, we got sine and cosine rules. Okay, so it's not something that's not drawn for us, okay, but we can draw it ourselves now. So I've got the longer side of the triangle is 2x minus 1. The other side has a length of x minus 1 and then an x plus 1, and then the largest angle is 120. So if I kind of draw out roughly what this might look like, okay, so I've got a triangle like that. Okay, there's my triangle. Okay. And I label my side. So my longest side, let's say it's this bottom one. It's basically the longest, okay, is 2x minus 1. And then my other sides must be x minus 1 and x plus 1. Okay, now the largest side and largest angle are always opposite each other. So that means this angle must be 120. Okay, now if I look at this, it wants me to, for part A, it wants me to find the value of x. Okay, now to find the value of x, if I look at what I've got the three sides and I've got an angle. Okay, if I've got three sides and an angle, that means I must be using cosine rule. So I'm going to write the word cosine rule down. Okay, and I'm going to go from there with it. So that is a squared. So big A and little a have to be opposite. So that means a must be 2x minus 1. So I've got 2x minus 1 all squared is my other two side squares, so b squared plus c squared. Okay, take away 2bc, so x minus 1, x plus 1, and then cos of 120. Okay, now what I'm going to do is I'm just going to expand everything else. Okay, so this first bracket expanded, 4x squared minus 4x plus 1. Expand this, gives me x squared minus 2x plus 1. I'm going to stick some brackets so I know what I'm dealing with each time. This one expanded is going to be x squared plus 2x plus 1. So we kind of already see some things are going to cancel. Now, if I look at cos of 120, cos of 120 is minus a half. So if I times the minus a half times the minus 2, I'm going to end up with positive 1. So that those two change it to a positive and cancel out a little bit, okay? So that means all I need to do is expand this double bracket. So if I expand this double bracket, I get x squared. I would get plus x minus x. They cancel each other out, and then take away 1. Okay, so what I'm going to do is I'm going to tidy up that right-hand side of the equation, okay? So I've got 3x squared, okay? Then I've got minus 2x plus 2x to get rid of each other. I've got plus 1 minus 1, ends with plus 1 overall. Now you can see I can take things to one side here. Okay, so I've got x squared minus 4x is 0. I'm gonna solve this. Now they have something in common, so I can just make a nice single bracket here. Don't feel you have to force yourself to make a double bracket. If they've got a factor in common, make a single bracket. So that means x is 0 or x is 4. Now the length, this is quite often the case that only one of them is the answer. Now sometimes they can both be the answer. However, if I look at this, one of the sides is x minus 1. If x was 0, that would mean that this length is negative 1, and we can't have a negative length. So therefore, x must be 4. It's the only one that works. Okay, right, now we know what x is. Part B wants me to find the area. Now my area formula is a half AB sine C, so two sides and the angle between them. Okay, so my two sides and the angle between them have to be the two shorter lengths and the angle. Okay, so I've got x plus 1. Remember, x is 4, so that must be 5. I've got x minus 1, so this length must be 3. Okay, and then sine of 120. Okay, now all I'm going to do is I'm going to type in my calculator. Now it does normally spit you out in terms of roots, and it's always a good practice to write them down, okay, because sometimes it needs it in that kind of format, okay, but in this case it doesn't, so I am also going to round it to 3 significant figures. And there's my final answer for that. Okay, so we've got one more question to do, okay, and that is using our trig identities. Okay, so you've got two identities to remember, okay? We've got to be careful when we want them. So I want to find all the solutions for the equation of here. So now what I always do is I'm going to write out my equation, okay, so I know what I'm dealing with. In the interval, now this one's a little bit awkward. It's between minus 360 and 360, but we'll come to that at the end, okay? We need to find one solution first. Now, we can see there's a cos squared, so I'm leaning towards using sine squared plus cos squared is 1. Okay, now what's important is if we've got this kind of situation where there's something squared and there's like another one, like a sine in this case, I can't change this for sine. Okay, so I have to change the cos squared into a sine squared. So I'm going to say what I'm using. I'm using the identity sine squared x plus cos squared x is equal to 1. Now, if I rearrange this, cos squared x must equal 1 minus sine squared x. Okay, now I'm going to substitute that in. Okay, let me expand this little bracket I've got here. So 3 minus 3 sine squared x plus 1. And you can kind of see, although it's got sines instead of x, just x's, we've got a quadratic. We've got something squared, we've got just the sine, and then we've got some constants. So I'm going to take everything onto the right-hand side because I want to keep my sine squared positive. So that gives me 3 sine squared x plus 4 sine x. Now, this side, I would have had 3 plus 1, which is 4. So if I take it over, it's a negative 4. Okay, be careful of taking them over to the other sides and the signs changing and things like that, okay? So I'm now going to factorize. Okay, now again, some of you may want to do split in the middle term and do some work over on the other side, okay? Some of you may want to just go dive straight into, and that's fine as well, okay? So I've got my two signs. I know that because 3 is prime, so the only way of doing it is doing 3 times 1. Okay, and I'm going to work out what my other numbers are. So this will be minus 2. This would be positive 2. Okay, so we got to think about which way round they're going to go. Okay, now the reason why I've got them this way round, okay, is because if I think about it, 3 times positive 2 would give me 6, and then minus 2 times this would give me minus 2, so that give me positive 4 overall, and it times to make the last one. Okay, so that means if I solve those, that means sine x, if I solve this first, so it must be 2 over 3, or I've got sine x equals minus 2. Okay, now straight away we have a bit of an issue with this second one. Okay, sine, we gotta remember, only goes between 1 and negative 1. Okay, so this one here has no solutions. Okay, so that means I don't have to deal with that one. I'm just going to deal with this one. So I'm going to do inverse sine, okay, and it's going to give me 41.81 degrees. Okay, and what I need to do is I need to find the other solution. So this is where our interval is really important. Okay, now this is quite a big interval here. Normally, it's just between like minus 180 and 180, or it's 0 to 360. It's normally just a 360 period at some point. Okay, so what I'm going to do is I'm going to draw my graph. Okay, now this is obviously going to be quite a big one, so I'm going to look at both sides. Now the positive side for sine should look like so, where it goes 180, it goes 360. Okay, the other side is just going to come down first, like so. Now again, you're drawing a sketch. It doesn't need to be a big work of art. Okay, just a quick sketch. Now 41.8 would be about here. Okay, that's 41.81. Okay, and I'm going to think about all the little jumps I can do. So if I draw a line straight across, it crosses at different aspects by here and here as well. Okay, and by here. So I've got 3 other solutions to find in this range. Okay, so if I look at this top one, I'm going to have to do 180 take away 41.81. Okay, down here, I'm going to have to jump from minus 180 down, so I'm going to take away again. And then I'm going to have to go from minus 360 up, so I'm going to add 41.81. I'm just using this first solution to my advantage and jumping the same amounts. Okay, if I do that, I end up with the following solutions. Okay, 0.19. I get 100. Minus 221.81, and I get minus 318.19. Okay, now it has asked for it for 1 decimal place. I normally find all my solutions to another degree of accuracy, so 2 decimal places, and then I round them afterwards just in case. Okay, now generally when we do our final answer, we write them in order, so smallest to biggest. So minus 318.2. Then minus 221.8, 41.8 and 138.2. And again, I'm just going to put my degree sign on to make sure it's clear. Okay, so I should have had 4 solutions from that. Okay, if you've only got 2, make sure you're thinking about this negative side as well. Look at the interval. Okay, but apart from that, make sure you've marked all that now. Okay, and then you can move on to Unit 2. Keep going, really, really well done. Make sure you made a note of the level of support you got to. But apart from that, okay, I'll see you in the next video. Okay, guys?